Hi, this is Arkadeep. Today me and my fellow mates Tenzing and Sunit are going to explain Sieve of Eratosthenes. Now Tenzing will explain Sieve of Eratosthenes and Sunit will further discuss about the code.
Good morning, this is Tenzing Palkye and I'm going to give a brief introduction on the algorithm Sieve of Eratosthenes. Sieve of Eratosthenes is an ancient algorithm for finding all prime numbers up to any given limit. It is one of the most efficient ways to find small prime numbers. The algorithm is very simple. At the beginning, we write down all the numbers between 2 and n. We mark all proper multiple of 2 as composite since 2 is the smallest prime number. A proper multiple of the number x is a number greater than x and divisible by x. Then we find the next number that hasn't been marked as composite. In this case, it is 3. Which means 3 is prime and we mark all proper multiples of 3 as composite. The next unmarked number is 5, which is the next prime number, and we mark all proper multiples of it, and we continue this procedure until we process all numbers in the row. To sum it up, a number is prime if none of the smaller prime numbers divides it.
Hello, my name is Sunit and I'll be explaining the code that we came up with. So we'll start with the standard procedure, that is include and void. Now the first step would be to declare n and take input from it from the user using scanf. Since we will be using array to the code, we will add a statement n is equal to n plus 1 because in an array the elements start from 0. So if the user puts 100, the elements would be 0, 1, 2, 3 to 99. So n is equal to n plus 1 statement will increase the input to 101, which will result in 0, 1, 2, 3 to 100. Now we will declare 3 more variables I, j and num, and also array with size of n, which will be the user input. Our basic concept when building the code was that we will mark all numbers or elements inside the array as 1. Then we would mark all the composite numbers using another loop as 0. So the elements which are remaining as 1 will be prime. So we will start the code using for loops and marking all the elements as 1 by using I is equal to 1, I is smaller than equal to n, I plus plus, and array I is equal to 1. Now we'll add a statement as num is equal to sqrt bracket n. For example, if n is equal to 100, then num would be 10. For the second loop, we will use for I is equal to 2, I smaller than equal to num, I plus plus. For example, if num is 10, the I will be 2 to 10. Then we will put if array I is exactly equal to 1, we'll start with another loop, which will be the main formula to mark out the composite numbers as 0. The loop is for j is equal to I into I, j is smaller than n, j plus equal to I. Array j is equal to 0. For example, if I is equal to 2, the formula gives us 2 squared, that is 4, and j is equal to j plus I, that is equal to 4 plus 2, that is equal to 6, and the 2 will keep on adding until j is smaller than n, thus making all the multiple of 2. Same with 3, 5, 7 till num. Now the composites are marked as array j is equal to 0, so the left out array I is equal to 1 will be prime, thus we print out array I. We put the print statement prime numbers till %d are slash n minus 1. We put n minus 1 because we increased n at the beginning as n plus 1. Now if array I print %d t comma I, we put t to add spaces between the numbers for easier readability. So now let's test the code. Let's put 100. So the prime numbers till 100 are, as it shows, 2, 3, 5, 7, 11 etc. till 97. Now let's try 1000. So here's the output.
Start this conversation